Yes, today we are going to discuss the chapter electrochemistry. First we discuss some important theoretical points, then objective questions. Okay, first point in this chapter is galvanic cell or electrochemical cell. What is galvanic cell or electrochemical cell? A simple electronic device, it converts chemical energy into electrical energy. It's known as galvanic cell or electrochemical cell. A simple example for galvanic cell is Daniel cell. Simple example for galvanic cell is Daniel cell. Okay, Daniel cell consists of two half cells. A copper half cell and a zinc half cell. Concentration is 1 molar and here concentration is 1 molar, right? Galvanic Daniel cell consists of two half cell, copper half cell, that is copper dipped in copper sulfate solution, and a zinc half cell, zinc dipped in zinc half cell, zinc dipped in zinc sulfate solution. Clear? Here oxidation takes place. Zinc become Zn2 plus 2 electron. And here reduction takes place. Copper 2 plus 2 electron gives copper, right? Here oxidation takes place and here reduction takes place. Electrode at which oxidation takes place is known as anode. Okay. Electrode at which reduction takes place is known as cathode. Flow of electron from anode to cathode. Flow of electron from anode to cathode. Flow of electron from anode to cathode, right? Due to oxidation, concentration of Zn2 plus increases, right? Concentration of Zn2 plus increases. That is, zinc becomes Zn2 plus. Due to oxidation, concentration of Zn2 plus increases. Due to reduction, copper 2 plus become copper. That is, concentration of copper 2 plus decreases, right? It acts as negative terminal. Next point is it acts as negative terminal and it acts as positive terminal, right? Okay. Galvanic cell means a simple electronic device which converts chemical energy into electrical energy. Simple example for galvanic cell is Daniel cell. Zinc dipped in zinc sulfate acts as anode half cell, and a copper dipped in copper sulfate that acts as cathode half cell. Two half cells are connected through voltmeter and solutions are connected through salt bridge. Here oxidation takes place. Here reduction takes place. Electrode at which oxidation takes place is known as anode, and electrode at which reduction takes place is known as cathode. Due to oxidation, electron flow from anode to cathode. Flow of electron from anode to cathode. Due to oxidation, concentration of Zn2 plus, zinc becomes Zn2 plus. Concentration of Zn2 plus increases. Due to reduction, copper 2 plus become copper. Concentration of copper 2 plus decreases, right? Okay. It's considered as negative terminal and this considered as positive terminal, right? Okay, it's electrochemical cell and simple example for electrochemical cell is Daniel cell. Clear? Overall reaction in Daniel cell. See, overall reaction in Daniel cell. Daniel cell. Okay. Zn gives Zn2 plus 2 electron. Cu2 plus 2 electron gives Cu. Overall reaction. Add these two equations together. Zn plus Cu2 plus cut. Zn2 plus Cu and this is overall reaction. It's a redox reaction. Here oxidation of more zinc changes from 0 to plus 2. Copper 2 plus become copper. It's a redox reaction. Here is increase of oxidation number and here decrease of oxidation number. So it's a redox reaction. Due to the result of this redox reaction, electrical energy produced in Daniel cell. Okay. Yes. Next important point in this chapter is reduction potential. Reduction potential means measure of a measure of ability of an electrode to gain electron is termed as reduction potential. Measure of ability of an electrode to gain electron is termed as reduction potential. Listen, standard reduction potential of copper electrode is 0.34. What is meant by standard reduction potential? Reduction potential of an electrode is measured by coupling with standard hydrogen electrode. Remember one thing, coupling electrode concentration should be 1 molar and standard reduction potential of hydrogen electrode is assumed to be 0. It's an assumption. Assumed to be 0. Listen, standard reduction potential means reduction potential of an electrode measured by coupling with the standard hydrogen electrode. Remember, coupling half cell concentration should be 1 molar. It is termed as standard reduction potential. Listen, standard reduction potential of zinc electrode is minus 0.76. Listen, copper having positive value and zinc having negative value. Copper having positive standard reduction potential value and zinc having negative standard reduction potential value. Listen, a metal or half cell with a positive standard reduction potential value means that half cell have a high tendency to gain electron compared to hydrogen. High tendency to gain electron. High tendency to gain electron compared to hydrogen. And zinc half cell having negative reduction potential. That means zinc half cell have a high tendency to lose electron. High tendency to lose electron. Listen, a metal with high tendency to lose electron, it is highly reactive, right? Highly reactive. Metal with a high tendency to lose electron is highly reactive. Metal with a low tendency to gain electron, high tendency to gain electron. Metal having high tendency to gain electron is less reactive. Less reactive. Okay, listen, reduction potential means measure of ability of an electrode to gain electron. That termed as reduction potential. Reduction potential measured by coupling with standard hydrogen electrode is termed as standard reduction potential. Standard reduction potential means coupling half cell concentration should be 1 molar. Coupling half cell concentration should be 1 molar, right? A metal with a positive standard reduction potential means that metal having high tendency to gain electron compared to hydrogen. That metal having high tendency to gain electron compared to hydrogen. Metal with a lower reduction potential, negative reduction potential means that metal having high tendency to lose electron compared to hydrogen. Clear? And this metal is less reactive, high tendency to gain electron. That metal is less reactive. That is, metal with a high reduction potential value is less reactive and metal with a lower reduction potential value are highly reactive. Clear? Then what is meant by electrochemical series or reactivity series? What is meant by electrochemical series or reactivity series? Reactivity series means arrangement of different metal in the decreasing order of reactivity is known as electrochemical series. Arrangement of different metals in the decreasing order of reactivity is known as electrochemical series. Top of the metal in the top of electrochemical series are highly reactive and reactivity decreases from top to bottom. Reactivity decreases from top to bottom. See, electrochemical series, lick, basar, ka-na. It's a shortcut to remember. Electrochemical series, lick, basar, ka-na, mug, alsan, lick, basar, ka-na, lithium, potassium, barium, strontium, calcium, sodium. Lick, basar, ka-na, mug, alsan. Next is Crophiconi hydrogen. Crophiconi hydrogen. Chromium, iron, cobalt, nickel, hydrogen. Then chapa. Copper, mercury, silver, platinum, gold. It's electrochemical series. Reactivity series. This metal is highly reactive and this metal is less reactive. Arrangement of different metal in the decreasing order of reactivity is known as electrochemical series. Listen. Lithium is highly reactive metal. And gold is less reactive, right? Less reactive. Lithium is highly reactive means metal with low reduction potential value are highly reactive. Remember, metal with low reduction potential value are highly reactive and metal with high reduction potential values are less reactive. So, this metal having low reduction potential value. This metal is having low reduction potential value. Potential value. And this metal having high reduction potential value. High E0 reduction value. Right? It's a reactivity series. Lick, basar, ka-na, mug, alsan. Crophiconi hydrogen. Then chapa, copper, mercury, silver, platinum, gold. Listen, lithium is highly reactive and gold is less reactive, right? Lithium is highly reactive means lithium having high tendency to lose electron. Gold is less reactive means gold having high tendency to gain electron. Metal which are highly reactive having low reduction potential value and metal which are less reactive having high reduction potential value. Metal with a high reduction potential value are easily get reduced, right? Metal with a low reduction potential values are easily get oxidized, right? Metal which are easily get reduced are good oxidizing agent, good oxidizing agent or oxidant. And here metal which are easily oxidized are good reducing agent or good reductant, reducing agent or reductant, good oxidant or good reductant, right? The important point is lithium is highly reactive. That means lithium having lowest reduction potential. Metal with a low reduction potential value are highly reactive. Metal with low reduction potential values are highly reactive. Low reduction potential means high tendency to lose electron. High reduction potential means high tendency to gain electron. That is, metal with low reduction potential values are easily get oxidized. It's a good reducing agent. Metal with high reduction potential values are easily get reduced. It's a good oxidizing agent. Right? Clear? Okay. Reduction potential for metals. E0 Ag plus standard reduction potential of for metal 0.80. E0 Cu2 plus bar Cu 0.34. E0 Zn2 plus bar Zn minus 0.76 and E0 Fe3 plus bar Fe minus 0.77. The standard reduction potential values of 4 metals are given. Question: which metal is easily get reduced? Which metal is easily get reduced? Metal is easily get reduced. First question. Next is easily get oxidized. Easily get oxidized. Next, good reducing agent. Good reducing agent. Reducing agent. Good oxidant. Good oxidant. Oxidant. Highly reactive. Highly reactive. Highly reactive. Decreasing order of oxidizing power. Decreasing order of oxidizing power. Oxidizing power. We have 6 questions related to these values. Which metal is easily get reduced? Element with a high reduction potential easily get reduced. Metal with